So, hello everyone. Yeah, we are back and live, and let's just check whether. Come on. Just check whether. Okay, seems like this I think is fine, and just wait a minute. Sorry for that. Had a little trouble there, and today I'm messing up a lot of the things actually. I just accidentally plug my mic to charger instead of my laptop. It's worried me so much because that charger is actually a higher volt. Thank God the mic is still working. Looks like safe. It's the reason because the USB cable is actually only capable of transferring 5 volt up to 5 volt or something like that. So I think I'm safe, but I'm not sure what actually happened there. You know, it's happened. We cannot change the reality. It is what it is, and we need to accept it. That's how reality works, isn't it? So let's get into the topic. Actually, last few days we are trying to build this PyTorch like thing in Rust. PyTorch thing in Rust. Actually, we have built some of basic functionalities, and now let's get into the before implementing the operations. Let's just get into this. Actually the backward pass. Actually, we are actually we need a backward pass, right? So before defining a lot of operations by ourselves, before writing code for the operation, something like a matrix multiplication and addition, the division, these kind of things, there is so many operations actually we need to care about, because For tensor matrix multiplication, it's very simple, and we can do that. We can do that in a effortless way. But for activation functions, it's a total another story. It's a different story, right? Because you that is you are having these weird formulas for uh, converting linear function into some sort of a non-linear, and you are maximizing using you are actually trying to maximizing the learning of that function. It's much more complex than that, so it's much more complex than normal operations like you know tensor multiplication, addition. These are the things are very simple, but for you know that's going to be a nightmare, I think. But anyway, we need to build that, right? Otherwise, there is no reason we are building this library at all. So before get into that, I just want to pass and implement this part for back propagation actually, so that we can check at least we have some model, and that can both forward and backward. Okay, what I mean, do you understand what I mean? So the I think I hope it makes sense. And another thing is that once we got some sort of a forward and backward, we can implement simple neural net, right? Instead of just writing every functions, every activations. So once we finished it, then we are getting to the backward passport. Instead of doing that, we can just creating writing both of them step by step, so that we can balance our results and understand how the library is working. So we can have actually much clear view than that. Okay, so for that I decided to do this, and here I'm just backward function, and it's going to be a take a layer. And another thing, what it's going to be, no, nothing. It seems like so another thing I actually wanted to change. Oh my god, what happened? Just wait a minute. Hey, mm, yeah, and we don't need this and this as well. Now this tiny grant. Okay. So let's get into this. So the thing is, okay, where is that? Before that, I want to change something here. It's in open settings, and it's preference Vim. Actually, it's what is it? I think it is. I just oh, it's not. So the thing is, it's really hard for me to just click this Control plus C for switching between command mode, right? It's really, I don't like it. So instead, what I want is just setting. But the another thing about I really don't like about VS Code is that I cannot set my Vim motion, like basically the by default Vim motion. If you are using Vim motion by default, in order to change between insert mode to command mode, you need to use escape key, right? So that's how you change between them, not between them, but insert to command. uh, you can use control plus C as well. that's also work, but for some scenario it's basically for different purpose, but you can use this most of the time. I think, I don't know the specific situation where it's serving for different purpose. I don't know, but I it's I think Primachan, he's the one told that said that control plus I use control plus C, but control plus C is for different purpose or something like that, but I don't know why. But another thing I want to point out here is that in my VS Code I cannot set this escape key to caps lock. I don't know why. I just even changed my escape key to, I mean, basically setting escape functional to caps lock in a system level, right? In a OS level. So if I am using another other than VS Code, if I click something like a caps lock, it's going to be act like a escape key. In VS Code, I think it acts like a escape key, but it doesn't change to the command mode. It makes me I don't know how I put this. It's, it's a pain. I just want to change this to at least shift plus caps lock, so that I don't know, but I don't know the exact configuration for it. The file I'm searching, I don't know which file I just wanted to change. Open settings UI. This is the one? No, this is the one I'm actually in. And preference. It's I don't know what it is. I think it's a key map. No. Okay, it is what it is. Maybe we can find that later. But for now, let's get into the work. Let's implement this. It's F1 backward. So it's going to be a backward, and it's going to be take a mute self. That's it. All we need is that's it. Now we have a mute self. So what we are trying to do, we are trying to basically find a derivative for each set of layer, right? If it is going to be a linear layer, okay, the loss, okay. So the thing we want to know is that another thing we want to actually we have to do. I'm not sure whether we have to do here on the tensor class, but actually I'm implementing that feature where you are actually you are actually if you're adding two set of layers, you need to know this two set of layers is added. Okay, you need to know the operation, right? So for that, but I'm not sure where to put this, because do we need to put this in a tensor or a linear layer? So tensor is actually okay, linear layer is actually wrapping the tensor. So when you backward it, actually you need to know that this layer, okay, you have this specific layer and its weights and back. So what we have now, all we have now is a self. So that just basically means that you have this layer, linear layer, and you are going to have weights, right? So all you have this weights, but what you need in order to find derivative for that weight, In order to find derivative for that weight, you need to have loss. Okay, you need to have the loss, otherwise you're not going to do anything. And another thing what we need, okay, you have loss and you have layer, that's it. And the, yeah, you need to know the operation. Okay, so whenever the tensor is, oh, okay, I understand. So it's in a add class. Okay, let's just okay, let's just ask that GPT, hey, I want to implement both. I want to implement up default operation. I want to implement add, okay, operations trait for my custom tensor. Maybe we can just launch this, and I have a struct called tensor, and I want to implement add sub mul something. Can you write optimize, write code. So here we go. Okay, what is the problem? Live, whether it's let's get into the topic. Actually, this it's the pain. Just change this to what this does. So this is okay. We have a tensor. Where is the function? This is the add trade, subtrade. Let's just copy those. See. Now, another thing I want to say is that in today's live, I'm not going to stream for like 2 hours as usual. Today, I afraid we are not able to do that. It's because no. I have some very important thing to do. I couldn't basically I cannot avoid that. So sorry for that. Even though I still need to say, even though even though nobody is actually watching my live, I need to still need to say this, apologize for my mistakes, right? Mistakes or things I want to apologize. Okay, so here we have some sort of a thing. What is this almond white? Oh, this is the function. Okay, let's assume. Oh, wait a minute. Where is that function? So let's just copy paste this. The reason the reason I'm just pasting these stuffs like I don't care is because we will optimize this later. For now, all we need to do is just get this thing working. Okay, so the F is a operation, right? Where what does this mean? I don't understand. Let's just ask GPT for it. Okay, data. It's I don't think it's data. What is it? Yeah, yeah, it is a data. Okay. So the f is actually a function taking okay. I just see let's just test this whether whether it's actually working or not. We can test this and okay, what we have here. So we need to write something here as well, because if we are adding this to we will not add linearly. We will not do that. Maybe we okay. Let's just use grad tensor. It's a tensor. Okay. So let z is equal to tensor it's a new yeah it's new. And what are the things we need to send here for the tensor class? Shape, grad, and type record. Okay, so three things. So which are the one? So make this as an optional, right? optional grad, so it's not optional thing. Okay, grad is not optional thing, and type, so no, it's both of them shouldn't be optional. So let's just it's a vector of u size, so something like 5 comma 5 is 25 elements, and false, right? And type normal, let's just or not. So norm, actually it's did I make this option field? Yeah, it's optional, and we are setting okay. So normal to string. So now it seems fine, and so here all we need to change is this, and for let's just add those. Okay, let create a some k z. Remember, we are not put this work, and I have to check that we need to print them, right? So but do we have any sort of thing for printing? Maybe let's just, you know, wrote some sort of a print, and it's going to be take a self. Okay, it's going to be take a self, and return, it's not going to be return anything, and a for in self, it's going to be a very dummy loop, so don't worry. For j and I, print ln, this is k. Could this work? We are taking a shelf, and so actually it's not going to work. I'm thinking like C. I'm basically thinking like a C programmer, because in C you can have like, you can, where if you want to print a 2D matrix, you have to do like this, because you're going to fetch each row, and you need to print each element in that row, something like that. But but in Rust it's not the case, because the entire array is kind of a flattened array, so it's so you can what you can actually do is just do something like this. That's it. So you're going to print that element. um this is the element, and can we do this? Could this work? So it's okay. And another thing I just basically forgot to do here is it's dot weights. It's a dot data, right? It's a dot data, and when you add this, you're going to put this. Okay, that is a problem actually. So So we need to basically, we have this deep copy thing, right? So actually, let's just do something. Mute, we don't mute. So let's just if J, okay, data here, bool, how much, today I just I can only stream up to an hour and a half hour, nothing more than that. I just basically want to keep in touch, so that's why even I have some amount of work. I just want to uh, at least I just wanted to stream with the hour I have, with the time I have. Okay, sorry for that, really. Such life. Data recur. So if data dot recur, then it's going to be so what I'm doing even here. If data dot recur equal to true, then we are going to return something like this. Maybe. Okay, this is, so what we are going to do is, okay, so here we are actually sending it, and there is a problem with it. It's because, wait a minute, actually, did I wrote this function inside of this function? Oh my god. So okay, no, I don't want this. I want this. So this is the function. It starts from here and it seems like fine, but the problem is we are sending this data actually. So this data, maybe we can, okay, maybe we can write another function for it instead of just, you know, instead of confusing all other parts, maybe we can write another function like f1 dot fill. Okay, this name makes sense, right? Because we are going to fill the data instead of going to be a it's going to be a F32. That's what we need, and all we need is the data shape dot clone, the shape. Okay, going to be shape is going to be vec of size, right? So that's, instead of call this, we can call fill. Now it will work. Okay, and it's going to be a return a tensor. The first tensor is actually okay. So now we have a, so all we need to do is, it's going to be okay. Let's put this as a self instead of that. So self, and data is equal to data, and shape 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 dot clone. Actually, maybe we don't need to do that, because then it's going to be self. So it's a self dot default, right? That's how it is, right? Oh, sorry for that. Okay, now it seems like now hmm. Okay, now we need to call fill, and it's going to be fill the data, and but data is actually expecting what it is actually expecting. Here we are sending us data, so data is TV, is a vector of F32. Taking this and self dot return it, and it's going to be give a iterable object, then you're going to be zip it. So zip it basically mean kind of taking two set of thing and put it in a single tuple or something like that, and your map on it, take the elements ops. So the op thing, where is this op? So app oh, okay. So wait a minute. So the op thing is playing. Okay. Wait a minute. What we are sending here is RHS and this entire thing. Okay, so self and the other, and this is the, so that's is basically replaced by, this is basically replaced by this, is it? Okay, let's just see whether it's okay. Just see. I'm 100% sure it's going to be fail, but just try. Why not? So we have 20 minutes more. Okay, we are missing semicolons. Fine. Default. Expect find keyword. Okay. So the thing, okay. Let's just read all of the errors. Formatter specifier. Yeah, we are missing this. That's, I want to basically know what is the formatter actually. The tensor. So data require, didn't I just, now it's fine. Okay, it seems like we are in trouble. Just that today, sorry guys, I think I got to go. Unfortunately, I need to go now. Thank you for watching. If you're watching my live, thank you for watching, and I hope you learned something. I